Problem number 32. Keeping in mind that some elements violate the octet rule, draw a Lewis structure for each compound. And you're given two compounds. Now the octet rule is something that is used as a guide when drawing Lewis structures, but certain elements are able to violate that rule. The notable exceptions for elements that have less than an octet are boron. Boron tends to have 3 bonds, which result in a hextet. And then beryllium. Beryllium tends to form 2 bonds, which result in a quartet. So let's take a look at beryllium first, because that's the one in A. So beryllium has 2 valence electrons. It's in column 2A. So 2 valence electrons. It tends to form 2 bonds, and that's perfect because there are 2 hydrogens here. So, 2 hydrogens. And so here are the dot structures for all of the atoms. You can see beryllium will form a bond to each hydrogen. And if you connect the atoms together properly, it looks kind of like this. You can first position the atoms if you want. So you put the hydrogens on either side where, it's pretty obvious they're going to go. Okay, so there you go. The bonds are ready to be formed. Let's go ahead and form the bonds. And that is the correct Lewis structure for beryllium dihydride. And you can see that beryllium, after bonding, has 4 electrons around it. Okay, if you have a boron compound, I know there's not one in this problem, but if you have to draw Lewis structures for anything involving boron, boron is in group 3A, so it has 3 valence electrons, and it would look kind of like this. Okay, so here's boron, 1, 2, 3 valence electrons, and after it forms its bonds, okay, one possible compound is BH3. BH3. If you were to draw the Lewis structure for BH3, it would look like this. That's how you would start it, and then connect the bonds. And that's the correct structure for BH3. Okay, BH3. And that also violates the octet rule with less than 8 electrons. This has a hextet, I guess you could call it. Okay, but there is the octet rule. Most atoms and molecules tend to have an octet. And if you're examining carbon, nitrogen, and oxygen, which are so important, these always have an octet. So carbon, nitrogen, and oxygen always have an octet. You should be very familiar with the way that they typically bond. Okay, now if you're dealing with elements that are in the 3rd period or below, then expanded octets are possible. So 3rd period and below, expanded octets are possible. So this problem has us look at PCl5, phosphorus pentachloride, PCl5. Now phosphorus has 5 valence electrons because it's in group 5A, and then the chlorines each have 7 because they are in group 7A. Using symmetry as a guide, it's always good to do that. You got 1 phosphorus and 5 chlorines. The chlorines are going to surround the phosphorus. Okay, and let's just go ahead and do that. So you put phosphorus in the middle, maybe a chlorine up here, 1 down here, maybe 1 over here, and maybe 2 over here. Okay, now the way we've drawn chlorine right here with its 5 valence electrons looks like it will typically will only form 3 bonds, and that's what it typically does. Okay, I'm sorry, phosphorus. It looks like phosphorus will form 3 bonds, but it's allowed to form 5 bonds and have an expanded octet. Okay, and so all 5 of these valence electrons, you just unpair these two up here. So let's do that. We'll unpair those two and kind of point them towards the 5 chlorines. Okay, so that's what the 5 valence electrons on phosphorus would be like. And then the chlorines, let's just keep those like that, since they typically form 1 bond, and that's all they need to do in this case, form the bond to the phosphorus. So the chlorines, this will be a lot of dots to draw. Let me draw all of these dots. 3 and then a dot. 1, 2, 3 and a dot. 1, 2, 3 and a dot. 1, 2, 3 and a dot. And finally 1, 2, 3 and a dot. Okay, so you can see phosphorus has a single electron pointing towards this chlorine, and it does for all the other chlorines as well. And now go ahead and pair up those unpaired electrons. So, oops, let me get that back there. Pair them up, try to keep this kind of neat. And then over here, okay, that first one is a little sloppy. Okay, there we go. So that's phosphorus pentachloride. And you can see by forming the 5 bonds, it has 10 electrons around it. So that's an expanded octet. And just be aware that for 3rd period elements and below, expanded octets are possible.